we want the left and right hand derivatives for this function at x equals 2. Now it's a piecewise function, so the left hand side and the right hand side are actually going to matter because the junction point happens to be at x equals 2. So the left hand derivative, that's what's denoted by this, is going to be the derivative of this piece here because it's on the left of 2. So the derivative of 3 minus x is simply negative 1. That's easy enough. You can plug in 2 if you want, but there's no x to plug in, so we're just left with negative 1. How about the derivative of 1 over 3 minus x? I'm going to encourage you to rewrite that as 3 minus x to the negative 1, so that when I take this derivative, the negative, I'm going to use the chain rule here, the negative 1 comes down in front, 3 minus x now to the power of negative 2. The chain rule says multiply by the derivative of the inside function. So the inside function here is 3 minus x. Its derivative is negative 1. So I'm going to say times negative 1 out here. That actually cleans this up. Negative 1 times negative 1 is positive 1. So this derivative ends up being just 3 minus x to the negative 2. And 3 minus x to the negative 2 is another way to rewrite 1 over 3 minus x squared. Now we're going to plug in x equals 2. 3 minus 2 is 1. 1 squared is 1. 1 divided by 1 is 1. Now, these are the left and right hand derivatives for this piecewise function. Is the function differentiable at x equals 2? That is to say, what is f prime of 2, or does it even exist? Well, kind of like limits need to exist from the left and the right, so too does a derivative. The left hand derivative is negative 1, but the right hand derivative is positive 1. So the derivative at x equals 2 does not exist.